In mathematics, has already been mentioned, a lot of problems are recorded as equations which are needed to be solved. In these questions in the algebra quiz, 18, 19, 27, simple equations need to be solved, or something similar, like the question 27 is a little bit different. You don't find a number there, you are just doing rearrangement, but approach is still similar to the equations that you'll see in the algebra quiz. Some equations, like this one in question 18, you hopefully can handle pretty easily, but just go through the steps. What we need to do here is find x, if possible, and in this case for linear equations we've got x to the power of 1 only. Quadratic equations we'll consider separately. You always have a solution. How do we find this solution? What you need to do is to try to separate x and numbers into different sides of the equation, but do this according to the rules of algebra. Now here we want to first get rid of this 7. How we can do it? We can plus 7 to both parts of the equation, to the left hand side and to the right hand side. On the left hand side, minus 7 plus 7 gives us 0, and therefore we just have 3x by itself. And on this side it will be 8 plus 7, which is 15. Next step is to get rid of these 3. How we can do it? We're dividing by 3 both parts. This way this cancels, and we have x, and here we've got 15 divided by 3, which is 5, which is a solution to this equation. We found a simple solution to a simple equation. It's number 5, but sometimes we might make a mistake, so it's a good idea to check this, especially it's so quick to check it. Go with this 5, substitute it into here, get 3 times 5, 15 minus 7. Even without a calculator you can see that if this is indeed 8. So 3 times 5, 15, 15 minus 7 is 8. Therefore this is a correct solution. We record it in a box and got a big fat tick for this question in the algebra quiz. Another question is very similar, and the only difference is that some fractions are involved. So hopefully once again you can do it ahead of me while I just formulate this equation. So we have 4 over 5x minus 9 all equal 3. How do we solve that? Once again we add 9 to both sides of the equation. So we have this 9 disappearing onto the right hand side as 3 plus 9, which is 12. And then we divide both parts of this equation by 4 over 5, which will have 12 over 4 over 5, and that is 12 times, remember 5 goes up, 4 on the bottom. Go to the fraction revision if this is still difficult. Before I'm multiplying, I'm better off cancelling these first, because 12 divisible by 4, so we divide, we get 3. 3 times 5 is giving us 15. So x is equal 15. Once again, check the answer. Substitute 15 into this simple equation. We get 15 divided by 5. We get 3. 3 times 4, 12. 12 minus 9 is 3. So we've got correct solution. Now that's solving equations, finding numeric value for x, but sometimes you need to handle equations, and in question 27 you give an expression with x and y. You've got 4 over y minus 7x equals 3. And the question is to find a formula which gives y in terms of x. So these two values are connected using these equations. And if you put certain value for x, you can find numerical value for y, but it's better to actually express it once and then have a simple formula, hopefully a simple formula for y. How we should do that? Well, once again, we separate things with y on one side, and we achieve that by adding 7x to both parts of the equation. So in a way it's similar as putting these on the left hand side and changing minus to plus, but the rationale is that we are doing the same thing to both sides of the equation, which is adding 7x on both parts of the equation. Here it cancels, here we have 7x. What we don't like with this expression is that y is still in denominator. Therefore, what we might do is multiply left hand side and right hand side by y, because we don't like it being in denominator. Yes, it puts it together with x momentarily, but we will resolve that later. So what we've done here is multiply these two parts of these by y. Here the y disappears, we only have 4, and we have this expression. Now, therefore, this, to extract y, what we need to do, put it on the left hand side, we divide both parts of the equation by 3 plus 7x, so that we remove that here, have y by itself, and here we'll have 4 divided by 3 plus 7x. Quite simple, and the answer therefore should be written as y is equal 4 divided by 3 plus 7x. Is it similar to this? Quite similar, I think, but a little bit more challenging because you've got x and y, and when you first separate them, y is in denominator. So one way is to do it like that, and that is what I've done. Another way is you can flip that. When you're flipping, essentially what you're doing is you're dividing 1 by this, 4 over y, and it should be equal 1 divided by this. That's another approach, if you like, which will achieve for us that becomes, remember the rules for fractions, y goes into numerator, 4 stays in denominator, and here you've got this 3 plus 7x, then 4 goes to this, you multiply both sides by 4, 4 disappears here, and you get exactly the same expressions. How you do it is up to you. Either way is right, so you can flip that as what I've done in here. So even without going to here, which was rationalizing that, this goes to top, this goes to bottom, this goes to bottom and 1, because you can always record this as 3 plus 7x divided by 1, division by 1 gives the number itself, as does multiplication. So you can do it either way, providing that you can quickly do this and reliably and without mistake. That will be important. So this is simple equation, and we'll do quadratic equations separately.